Hi, we're here to do section 7 of chapter 1, explicit formulas and sequences. Sequences are going to be something that comes back over and over. We have them here in chapter 1, we have them in chapter 3, they come up some other chapter. Explicit formulas are going to be one of two different types of formulas that we talk about with sequences. So first thing I have in the notes is just really what is a sequence? And a sequence, very simply, is going to be a list of numbers in a certain order. And there can be all sorts of different formulas or equations or patterns that you could have in sequences. So for example, just a real simple one, maybe it would be something like 2, 4, 6, 8. I'm going to do comma, dot, dot, dot. But most of you would probably guess the next number is going to be 10, and then 12, and so on. It's just even numbers, and we're going up by 2 every time. You could have sequences that maybe are doing something like this. You could have maybe like 2 and then 6 and then 18. You could look at, well, how are you getting from one number to the next? We're multiplying by 3. So then the next number would be 54? 30? Yep, 54. And so on. Then, or there could be a pattern that's a lot harder for some people to get. Something like 8, 6, 7, 5, 3, 0, and if you know the song, it's Jamie's phone number, so the next one would be 9. I don't know what you do with the dot, dot, dot. But anyway, it's just a bunch of numbers in a certain order. A term, when we talk about a term is really just going to be each of those numbers in the sequence. So each individual item or number in the sequence. So each individual item, or you could say number, in the sequence. So when we're looking at this first one, the 2, 4, 6, 8, so 2, 4, 6, 8, dot, 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 you could say that 2 is the first term. It's the first number, the first item in the list. 6 then is going to be the third term, the third number, the third item in the list. And you could go through and write all that out if you wanted to. You could say the first number is 2 or the first term is 2. But instead what they do is they have a much easier shorthand for it. And they'll pick a letter. It doesn't always have to be T. Our book kind of starts out with T. It could be an A, could be an S, could be an M, could be any letter really. And they'll say T sub 1. And the subscript here, kind of like submarine, subscript is below writing script. But the 1 stands for the term number. So T sub 1 then would equal 2. That's the first term, the first item in the list. If we were talking about the 8, you could say T sub 4 is 8. The fourth number, the fourth item, the fourth term in the list is 8. Okay, a new sequence. I'm going to pick, let's say, 6, 9, 12, 15. So if you take a look at that, it's going to be a sequence, starts at 6, and to get from one number to the next, each time we're adding 3. And if you wanted to, then you could say the 6 is going to be T sub 1, so I'm just going to write that kind of down below. The 9 is T sub 2, 12 is T sub 3, the 15 is T sub 4. Now if we want to take and try to write a formula, or an equation that's solved for a variable, a formula, to get this sequence, we need to have some way of kind of connecting our term number, our generic number, to the numbers in the sequence. And we do that by having, this is the weird part in the notes, but we need to have some way of having like a generic term out here. And the way that they do that is they call it T sub n. And n, if you think back earlier in this chapter, is going to kind of stand for the set of natural numbers, which are our counting numbers, our 1, 2, 3, 4, 5, 6, and so on. Because each of these subscripts is going to be a natural number. So I'll talk about T sub n, and this T sub n then is technically going to be the nth term. So it's the nth term. And once that we have that, now we can use that information to go through and actually write a formula for the sequence. So that t sub n is the nth term of the sequence. If you wanted to, you could say where n is an element of capital N, which is going to be the natural numbers. You could write that if you wanted to. Natural numbers. That's really sloppy. Okay, moving on. Roman numeral 2 then is going to actually be the using an explicit formula. And the whole key here, so Roman numeral 2 using an explicit formula, the whole key is put the number of the term you want to find in for n. So put the number of the term in for n and simplify. So one example of an explicit formula, we'll swap colors here, would be something like t sub n equals 3n plus 9. So if you're given a formula something like this, t sub n equals 3n plus 9, and say they want you to find the first 4 terms in the sequence. Well, if you're looking for the first 4 terms, sometimes when you're just starting out, it's helpful to kind of throw blanks down there. So we're looking for what are going to be these first 4 numbers in our sequence, in our list of numbers. This first one here is going to be t sub 1. So if we're trying to find t sub 1, the whole point is this number right there needs to be a 1, so it'll be t sub 1. So if n is 1, if you think back to our Euler notation from earlier in this chapter, it's kind of like the f of x. You take what's in that spot and you replace your variable with it. So now we take and we put a 1 in there. So 3 times 1 is 3, plus 9, we have a 12. So our first number in the list then is going to be 12. When we're over here looking for our second number, t sub 2, we do the same exact steps, but now a 2 is in that n spot. So we take and we replace the 2 over here with a 2, or the n over here with a 2. 3 times 2 is 6, plus 9 gives us the 15. And then over here, our third term would be t sub 3. So now our n becomes a 3. So 3 times 3 is 9, plus 9 is 18. And you just kind of go through and continue that process all the way through. What you could do, if you're really on the ball and awake, you could notice that every time n goes up by 1, the value, since it's 3 times n, the value is going to get 3 times bigger. And sure enough, we have another sequence where we started out here at 12, and we added 3, added 3, added 3. That's how I popped the 21 in there so fast. That's all we have for section 7. We'll do more sequence stuff in the next couple sections.